Welcome to Database Internals Crashcasts. I'm your host Sheila, and today we're diving into the fascinating world of query optimization. Joining me is our database expert, Victor. Hello, Victor.
Hi, Sheila. Great to be here. Query optimization is a crucial topic in database management, so I'm excited to discuss it with you and our listeners.
Absolutely. In today's episode, we'll cover the history of query optimization, its basic concepts, dive into more complex aspects, discuss real-world implementations, and share some best practices. But before we start, let's kick things off with a quiz question for our listeners. Here it is. In query optimization, what does the term cardinality refer to? Victor, any thoughts on this without giving away the answer?
Ooh, that's a great question, Sheila. Cardinality is indeed a fundamental concept in query optimization. I think our listeners might find it tricky because it's a term used in various contexts in computer science and mathematics. In query optimization, it has a specific meaning that's crucial to understanding how the optimizer works. I'm looking forward to hearing our listeners' guesses.
Excellent. We'll reveal the answer towards the end of the episode. Now, let's start with the basics. Victor, can you tell us about the history of query optimization? Why was it created, and how has it evolved?
Certainly, query optimization emerged in the 1970s as relational databases became more common. It was created because as databases grew larger and queries became more complex, finding efficient ways to execute these queries became crucial. Early optimization techniques were relatively simple, focusing mainly on deciding the order to join tables. Over time, as computers became more powerful and we developed smarter algorithms, query optimization evolved. It now includes more advanced techniques like cost-based optimization, using statistics to make better guesses, and adapting to changes as the query runs.
That's fascinating. So, it's been around for quite a while. Now, before we dive deeper, could you explain what query execution means in this context?
Of course, think of query execution like following a recipe to bake a cake. When you submit a database query, it's like giving the database a recipe. Query execution is the process of following that recipe to get your data. The database needs to figure out the most efficient way to mix the ingredients, or in this case, retrieve and combine the data. This involves deciding which indexes to use, in what order to join tables, and how to filter and sort the data. Query optimization is all about finding the best recipe to get your data cake baked as quickly and efficiently as possible.
I love that analogy. It really helps visualize the process. So, query optimization is like finding the best recipe for the query to follow. That brings us to cost estimation. How does that fit into the picture?
Great question, Sheila. Continuing with our baking analogy, cost estimation is like calculating how much time and energy it will take to bake different versions of your cake. In database terms, cost usually refers to factors like how much the computer's brain, CPU, needs to work, how many times we need to read from or write to the disk, and how much memory we'll use. The query optimizer estimates these costs for different possible ways to execute the query, and chooses the plan that it thinks will use the least resources. It's worth noting that these are estimates based on past experiences and educated guesses, not exact calculations.
That makes sense. Now let's dig a little deeper. Can you explain what a query plan is and how it's generated?
Certainly, a query plan, also known as an execution plan, is like a detailed recipe for how the database will prepare your data dish. It's a step-by-step blueprint for executing your query. The query optimizer is like a master chef who comes up with several possible recipes and then chooses the one it thinks will be most efficient. The process of creating these plans involves several steps. 1. First, it translates your SQL query into a language the database understands. 2. Then it applies some clever tricks to come up with alternative ways to get the same result. 3. Next, it estimates how much each plan might cost in terms of time and resources. 4. Finally, it picks the plan it thinks will be the fastest and most efficient. Each plan specifies details like which indexes to use, the order of table joins, and what methods to use for operations like sorting or grouping data.
Wow, that's quite a process. It sounds like the optimizer needs a lot of information to make these decisions. How does it know about the data in the database?
You're absolutely right, Sheila. The optimizer relies heavily on statistics about the data in the database. It's like the optimizer has a cheat sheet about what's in the database. These statistics include information like how many rows are in each table, how the values in columns are spread out, and how different columns relate to each other. The database regularly collects and updates these statistics. For example, it might keep charts showing how values are distributed in a column. This helps the optimizer make better guesses about how many rows will be returned by a particular operation. It's like knowing the ingredients in your pantry before you start cooking.
I see. So it's like the optimizer has a map of the data landscape. Now, you mentioned join order optimization earlier. Why is that important?
Join order optimization is crucial because the order in which tables are joined can dramatically affect query performance. Imagine you're planning a road trip to visit several cities. The order in which you visit them can greatly impact your total travel time and fuel consumption. Similarly, in a database query involving multiple joins, the order of these joins can significantly influence how quickly the query runs and how much computer power it uses. For example, if you're joining 3 tables A, B, and C, you could join A and B first, and then join the result with C. Or you could join B and C first, and then join with A. The best order depends on factors like how big the tables are and how well the join conditions filter the data.
That's a great analogy. It really helps visualize the process. Now, we've talked about join orders, but what about indexes? How do they factor into query optimization?
Excellent question. Indexes play a crucial role in query optimization. They're like the table of contents in a book, allowing the database to quickly locate the data it needs without reading the entire book. The query optimizer considers available indexes when creating execution plans. It decides whether using an index will be faster than reading the whole table. Sometimes it might even suggest creating a new index to make queries run faster. However, it's important to note that having too many indexes can slow down operations that change data and take up more storage space. So choosing which indexes to create is a balancing act between making queries fast and keeping the overall database running smoothly.
That's really interesting. It sounds like there's a lot of complexity involved in query optimization. What are some of the challenges or edge cases that database administrators might encounter?
You're right, Sheila. Query optimization can be quite tricky, especially in complex scenarios. Some common challenges include 1. Dealing with very large datasets where the statistics might become outdated quickly. 2. Optimizing complex queries with many joins, subqueries, or complicated conditions. 3. Handling data that isn't evenly distributed, which can throw off the optimizer's estimates. 4. Adapting to workloads that change frequently, where the types of queries being run keep shifting. An interesting edge case is when the optimizer makes a less than ideal choice because its information is outdated or the data is distributed in an unusual way. This is why it's important for database administrators to regularly update statistics and sometimes give hints to the optimizer for particularly tricky queries.
Those sound like significant challenges. Are there any common misunderstandings or pitfalls that people should be aware of when it comes to query optimization?
Absolutely, Sheila. One common misunderstanding is that more indexes are always better. As we discussed earlier, too many indexes can actually harm performance. Another pitfall is relying too heavily on optimizer hints without understanding their implications. While hints can be useful, they can also prevent the optimizer from adapting to changes in data or query patterns. A big one is assuming that what worked well in a test environment will work equally well in production. Production data volumes and distributions can be very different, leading to unexpected performance issues. Lastly, some people forget that query optimization is an ongoing process. As data changes and grows, queries that were once efficient may need to be re-optimized. It's like needing to update your recipe as your ingredients or kitchen equipment change over time.
Those are great points, Victor. Now, let's talk about best practices. what tips would you give to our listeners for effective query optimization?
Great question. Here are some key best practices. 1. Regularly update statistics to ensure the optimizer has accurate information. 2. Design your schema and indexes with your most common and critical queries in mind. 3. Use explain plan or similar tools to understand how your queries are being executed. 4. Be cautious with optimizer hints. Use them sparingly and only when necessary. 5. Consider partitioning large tables to improve query performance. 6. Optimize your queries themselves. Often, rewriting a query can be more effective than relying solely on the optimizer. 7. Monitor query performance over time and re-optimize as needed. Remember, query optimization is both an art and a science. It requires a good understanding of your data, your queries, and your database system.
Those are excellent tips, Victor. Now, do you have any interesting facts about query optimization to share with our listeners?
Indeed I do, Sheila. Here's a fascinating tidbit. Query optimization is actually what computer scientists call an NP-hard problem. In simpler terms, this means that finding the absolute best execution plan for a complex query is so difficult that it's practically impossible to solve perfectly. That's why query optimizers use various clever shortcuts and estimations to find a good but not necessarily perfect plan in a reasonable amount of time. It's a prime example of the trade-offs between perfection and practicality in computer science.
Wow, that is interesting. It really underscores the complexity of what query optimizers do. Now, to help our listeners remember the key aspects of query optimization, could you give us a memory aid or acronym?
Certainly. Let's use the acronym COST to remember the key aspects of query optimization. C. Cost estimation. The process of guessing how much resources different execution plans will use. O. Optimization strategies. Various techniques used to make queries run faster. S. Statistics. Important information about tables and columns that help the optimizer make decisions. T. Transformation rules. Methods for coming up with different ways to run the same query. Remember COST, and you'll have a good framework for understanding query optimization.
That's a great memory aid, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. The question was, in query optimization, what does the term cardinality refer to?
Ah yes, the quiz question. In query optimization, cardinality refers to the number of unique values in a column or the number of rows that match a particular condition. It's a crucial concept because it helps the optimizer estimate how selective a particular operation will be. For example, if a column has low cardinality, meaning it has few unique values, a filter on that column might not reduce the result set very much. This information influences how the optimizer chooses to execute the query.
Thank you, Victor. That's a great explanation. Now let's summarize the main points we've covered in today's episode. 1. Query optimization aims to find the most efficient way to execute database queries. 2. It involves generating and evaluating multiple possible execution plans. 3. The optimizer relies heavily on statistics about the data in the database. 4. Join order optimization and index selection are crucial aspects of query optimization. 5. Query optimization faces challenges with complex queries and large dynamic datasets. 6. Best practices include regular statistics updates, careful schema design, and ongoing monitoring. Victor, is there anything else you'd like to add?
That's an excellent summary, Sheila. I'd just like to emphasize that query optimization is a deep and evolving field. If we had more time, we could have delved into topics like adaptive query processing, multi-query optimization, and how machine learning is being applied to query optimization. These are exciting areas that are pushing the boundaries of database performance.
Thank you, Victor, for those insights, and thank you to our listeners for tuning in to this episode of Database Internals Crashcasts. If you found this information valuable, please subscribe to our podcast and leave us a rating. Your support helps us continue to produce high-quality content on Database Internals. Until next time, keep optimizing those queries.